Assalamu alaikum and welcome back to the Eduverse, a universe of learning. I hope you all are doing so well with your family, in a good health and with the joy. Today we are going to talk about a very important tool of the physics, that is about the multiplication of different type of products we have. That we actually we have the scalar product and the vector products. We will discuss about them. We will discuss about their examples and how they are different in results with one another, and what type of trigonometric function we will use in this product. First of all, we have the scalar product. What is the scalar product actually? We have definition. The scalar product are also called as the dot product of the two vectors results in a scalar quantity. In simple words, I can say that when we add or when we multiply two vectors and we will given with the answer that is a number, only number not having any direction, then we can say that means that a scalar. Then we can say that it's a scalar product, and the scalar product is represented with the dot between the vectors, like we will display the multiplication by dot, and the result of that dot product will be magnitude of A, magnitude of B, and with along with the angle between them, and the angle between them will be denoted with the cos. So it measures how much one vector goes in the direction of another. Yes, it actually measures the directions of the vectors and how much they are in one another, in the direction of one another, and that direction and that difference will be found by the angle between them. Involves magnitude and angle between the vectors. Yes, the angle and the vectors between and the magnitude of the vector and also the angle between them results in a number, not a vector. Yes, as I have discussed and I have told you before, that the result of the scalar product will always be a number, a single number, and a single number also called as scalar, that does not have any direction. So this also have and don't have any direction in result. So it's not a vector. Maximum when vectors are in the same direction means that if the cos is 0, means that A is also moving in this direction, B is also moving in this direction. So means that the direction between these two angles, no, sorry, the angle between these two vectors will be 0, and so we will put the theta is 0 over here, and the cos 0 will become the 1. So that will give us the maximum value of both the magnitude of both the vectors. So this point means that maximum, the result of this will be maximum when vectors are in the same direction. So I have told you that when there is no angle between them, it will as there will be a 0 angle between them, the maximum, the magnitude of both the vectors will be maximum and will be in the same direction. Physical example of the scalar product: work done. As we have, the work done is actually the force applied on a body in a direction or displacement, meaning that this is also a vector, this is also a vector. But when we multiply it as for finding about the vector for finding about the work done, we will apply a dot over there, because the work is totally a scalar product of the f and d, these two vectors, and the result will always be the scalar. Like, we don't say that work in that direction, work in that direction. Work is totally a scalar property. If the force is a long displacement, full work done. If the force is perpendicular, 0 work done. Okay, means that for example, if I want to show you, like with the if the force is a long displacement, if we have a body over there and we want to move it in this direction, so means that from there to here, from here to here, we want to cover this much displacement. So if we apply force along the displacement, means that if we force along in this direction, we pull it in this direction, the force and the work done will be full, means that the full work done will be happen, because the angle between them is 0 and cos 0 is equally 1, and 1 will be multiplied with them, and that will give us the full work done. But when we applied a work in this direction, no, sorry, a force in this direction perpendicular to the displacement, so our body will move in this direction, not in this, so we will have a 0 work done in this displacement in this direction. So because the cos 90 means that the angle between them is 90, the right angle triangle, and the cos 90 will give us 0, and the whole work done will be goes to 0. So in simple we can say that in this point saying, if the force is along the displacement, so the full work will be done. If the force is perpendicular to the displacement, so no work will be done. So this is how about the physical example of the scalar product. Now we have, sorry, I have to change it. Okay. Now we have vector product. Like, what is vector product? The vector product are also called as the cross product of two vectors result in a new vector. When we apply one vector with another vector, and after their multiplication give us another vector, like a property that will have a direction and have properties of the vector. So that type of product of the vector, we can say that vector product. If we have a two vector, we multiply them, and that the product of their multiplication give us another vector, so that will be the vector product. This is the simple definition. It represents a vector perpendicular to the plane formed by the original two. So it gives us only it's telling us about the perpendicular to the plane, the vector perpendicular to the plane, because it the formula we have, after that we will understand about this point. If you look about the formula, yes, the main point, the cross product is always will be represented with the cross between the two vectors, like we can see over there. A vector cross B vector give us the A vector magnitude, B vector magnitude, and sine theta and unit vector, and that unit vector shows about the direction, means that this whole on the right side will give will be the vector, because it has direction. So this is about the this is actually the formula for the vector product that we can describe, or we can represent it by this. So come to this point, because it always represents the vector perpendicular to the plane formed by the original two. So because means that it will give us the positive response whenever we have a maximum positive response, when we have the sine theta is 90, because on sine 90 the sine 90, it will give us the 1, and that multiplied to this, it will give us the maximum value of the, or maximum values, or maximum product of the magnitude of the vector. Direction found by the right hand rule. Yes, if we have two vectors, then applied, or we have two vectors, then we will how we will find about the direction. For example, if we have these two directions or these two vectors, this, okay. Now the direction of these two vectors, for example, we are given with this diagram, and A representing this one and B representing this one, and we have this cross product. Oh, so we will found so we will understand that yes, it's the vector product, so it must have a direction, and we are given with the question that to find the direction of this diagram or this graph. Then how we will find about that? Okay, first A1 is this, A is this, and this is a vector, and B is this. Sorry, little bit I am weak in the representing something. This is the origin. Okay, now we are given in the question that to find the vector product, and then finding about the direction between them, sorry, the direction of this vector product. So how we will find about that? Direction found by the right hand rule. Right hand rule we will apply on that on it, like we have fingers in this direction and have a thumb, like for example, it's our hand, it's our thumb, and these are the fingers. Okay, Now place your hand over there and curl it in the direction from A to B. So this is actually the curl of the vector. Now the thumb will be give us the product of the sorry, the product direction of this product, the resultant direction of this product. Sorry, the resultant direction, I want to tell you. So once again, I'm telling you how to apply that. Apply it. Place our right hand over here, over there. This is your thumb, and these are the fingers, for example. So now curl your fingers from A to B and make it closed. So the thumb will show the direction of this product. So the direction of this vector visualization will be out of the page, mean that it will go out of the page. If we have the direction from here to there, like the curling from our hand from there, then the direction of this vector will be vector product will be inside the page. But in this situation, we curl our fingers from point A or vector A to B, and then close the fingers in our hands, and then our thumb will shows about the direction of this vector product. So this is about actually finding about the direction of the vector product. 0 when vectors are parallel. Okay, when we have this type of equation, so if we put 180 in this theta, 180 will give us the 0, and also the 0 is also will give us the 0, sin 0. So the product or the result of this vector multiplication will be 0 if these vectors are parallel or anti-parallel, then the result will be 0, totally 0. Here we have here we have a physical example of the vector product, that is the torque, force multiplied by distance. We have cross, so we can say that it's a cross product, and the result should also have a direction, and the torque over here we have. Okay, this is the equation for the torque. It's actually the rotation axis, and also the force, and there is a cross product among them, so it will give us the direction of the torque. Torque vector is perpendicular to both force and position vectors. Maximum torque when force is perpendicular to the arm. For example, if we have, how we will apply that? For example, if we have this is on the xy plane. This is x-axis, this is y-axis, and for example, this is the z-axis. Okay. This is the z-axis. Force is in this direction. Angle of axis is arm axis in this. So here is the angle between them. Angle. Now we will curl our finger from there to there, from here to there, like by using the right hand rule. There will be our thumb, and the thumb will show the direction of torque, the direction of the vector product result. So this also written in this point. Okay. Torque vector is perpendicular to both the force and position vector. Here we have, for example, a position vector, it's the force. So for both of them, the perpendicular is in the z direction, and that z direction will be the torque. Maximum torque when force is perpendicular to the arm. So these are the two arms. So if the force is totally perpendicular to this, this is the arm, and force totally perpendicular to the arm. So the maximum torque will be given from this activity. So this was the physical example of the vector product. I hope you will understand it. And here we have a key difference between the scalar and the vector products. Result, the scalar product result will be always be scalar, and it will always be a vector. Means that it will always be just a number, and it will always be number, plus number shows the magnitude plus the direction as well. Formula: represented with the dot between the vectors. A dot b is equal to a b magnitude of a magnitude of b and cos theta. Here for the vector a cross b, a vector b vector cross between them is equal to a magnitude b magnitude sine theta plus with the and with the direction vector, unit vector. This cap is actually over there above the pen that shows the unit vector. Angle involved, there is a cosine among them, cosine of the angle, and here is you can see that is a cosine among them, and here we have the sine theta among them. So this is the actually the angle involved in them. Direction, no direction, as we know that the scalars don't have any direction, so the scalar product also has no direction, always a number only. But the direction of the vector product will always be perpendicular to both the vector using by the right hand rule, as we have discussed in the previous slide. Example work, we have examples about it, and also we have done about this example as well. Torque is example of the vector product. So this was the key difference between them. Conclusion, scalar and vector product are key tools in vector mathematics. Yes, it plays a very vital role in presenting the different physical quantities, different quantities. So these are actually playing a vital role in the vector mathematics and the key rules, in the key tools. They help calculate work, torque, magnetic force, and more. They are actually help us to finding about the work, torque, and magnetic forces, and more, all the different physical quantities. Understand the angle and direction of the correct for the correct applications. Yes, it also tell us about the angle between the vectors, angle between the two different vectors, and also about the vector direction. Means that the resultant direction of the vectors. It tell us about it for the correct application. For the correct application, whenever we use it in application or we want to apply it, so it will give us an physical understanding, and it will help us to finding about and try to apply a very in a very precise way. So this was all about for the today's lecture. Thank you for watching. If you found it helpful, so please like it and also share with your friends. That will be so much helpful for them as well. And don't forget to subscribe this channel, because Eduverse will always be here for solving your problems, to clear your topics, and also to remove your confusion of any type of. Whenever you have any type of confusion, you can contact me through my email, or you can suggest me something. You can contact me through my email, or can be in the comment box. Comment box will always be open for you people, and yes, also share with your friends as well, because Eduverse will always for you. And at the end, I want to tell you something, that this life is totally unpredictable, and you are maybe sometime you are waiting for the right time of your life, but the right time never came in your life. Your presence is actually a right time. So live in your present. Don't think or don't make any tension or don't take any tension for the future. Future is in the safe hands, and your future is always dependent on your today's activity. Go for it, work hard for it, stay tuned, and yes, the main thing is consistency. Consistency break a lot of hardness, hard thing. So always be consistent to your goals, and try to be kind with the people, because it costs nothing, and and maybe your kindness helps someone a lot and make change their life, and that will be so much awesome for you, for awesome for them as well. And yes, all that I want to tell you, and with every video I will tell you a lot, inshallah. And yes, thank you so much. I can say again, thank you so much, and Allah Hafiz. Stay blessed, stay tuned. Allah Hafiz, and thank you.